I got an 8 in it. Let me choose you. No, what's that 8? That's not the period. That's the what of the graph? Frequency. That gets you to the period. So now out of those two, we got to figure out which one's got a max height of 4. Well, they both have shifts, don't they? Before I shifted, before you shifted, where did it go up and down to? -4 to 4. -4 to 4. All right, first one, ready? I shifted all the points. Down 3, down 3, down 3. All right, what's your new minimum now? -7, and my new max? Okay, so I know that'll be the answer, but let's keep going. This one is a shift up 5. What's the new minimum? They're setting you up, man. They're setting you up. You see the 1, you're like, boom, circle it. But that's a minimum. I needed the maximum of 1. So that's why it's choice 1. All right. Everyone all good there? Be careful. We all going to get through this? I don't know how many are in here, but 100% passing here. 26. Come on. 26 points. You guys do a heck of a job on the multiple choice. You got nothing to worry about. All right. All good. All right. That's the only one I'm doing today, and probably I won't do any more until Thursday. All right, when we're done with the unit test, because our focus has to be on doing well in the stats unit on Wednesday, because I know some of you guys need to do well here. All right, let's go. 26, page 26. I want to finish, finally put to rest. How do I know the difference between the means is significant or not? All right, how do I know the treatment worked? How do I know if it wasn't by random chance? We've got to make this down pat. All right, so read about my garden example up there. And my tomato plants. Anybody a gardener, by the way? Tomato plants, anything? Do I have any in here? No, me neither. Okay. I was going to ask about if this really was something that people did. Plastic mulch. All right, what is the difference in the means here? On average, how much higher did the black plastic mulch grow than the ones without on average? About 5 ounces more. I guess we're doing weight, right? It weighed about 5 ounces more. All right, so that's, hey, they did it for you. You don't have to calculate the mean. You don't have to subtract them. They did it for you. It's 5. Now the next step, go to the simulation, find out where 5 is. All right, around where is 5 on the simulation? I don't know what they're going by, but I know 5 is halfway between 0 and 10, so about right there. All right, hey, look, listen. Many of you could probably say, yeah, it's pretty much in the middle, so it's by random chance. But that is not what you can write down. You got to show us mathematically why it's by random chance. So we're going to count how many are at or above that 5 right now. So go ahead, and we'll try to come up with a class consensus. How many are at or above that 5 right now? We know what the answer is going to be. I know it's by random chance. I get it, but we have to show why it is. Okay, different values you're getting. How many are at or above? I got 41. 41? Okay, 41 out of what? How many times they do this? 100? Oh, this is an easy one, right? 41%. What's our cutoff to be significant? It's got to be outside the 95, right? Which means 2.5 or 2.5. Within or outside? Within. So we say that it's by random chance and it's not significant. All right. It wasn't because of the mulch that we had a difference. All right. It wasn't because of the mulch. It was just by random assignment here. Yes. You all right? Okay. Other questions? Everyone doing all right today? You got to get through this week. Then you can enjoy yourself for a week and a half before I start grilling you. Packet, page 31. More tomato plants. I don't know where we're coming up with this, but instead of mulch, we're basically going to put one of the groups on steroids. All right, and see if there's why there's a difference in the weights. So you guys can go through right now, answer parts A, B, and C, and we'll talk. Means, difference in the mean. Yep. It's a 9. Okay, as you're computing, what did we get for Group A's mean? Group A's mean. Let's go 8. What do we get for Group A's mean? Nice job, 6.76. Group B's mean. 13. 6.48. It tells us please subtract the difference in the means by doing A minus B. 6.76 minus 6.48. What's the difference in those means right there? 3.28. All right, everybody stop, please. Everybody stop before you go to the simulation, because I'm going to ask this on Wednesday's test. What does that 0.28 mean as far as the problem goes? I don't want it's the difference in the means. I don't want it's in the middle. What does it mean as far as these plants go? What's that 0.28 represent? On average, Group A's weighs 0.28. I don't know. It doesn't give me any units. I'm going to assume ounces, because if it was pounds, we'd have some seriously big tomatoes on our hands, huh? So I'm going to assume ounces. So on average, Group A's tomatoes were 0.28 ounces bigger than Group B's. All right? Because I'm going to ask what that number means on Wednesday's test. All right. So we did the simulation. Is that 0.8 significant or not? All right. Is the 0.28 significant or not? So locate where 0.28 would be, everybody. Oh, boy. I guess I forgot to erase that arrow on the notes, huh? Everybody see that faded arrow there? 0.28. I think we know the answer if it's significant or not, but I'm sorry, mathematically, and I'll let you, just stop complaining. I know there was going to be complaints. I knew it, especially from this crew. All right. So I'll just tell you about how many there are. Okay. And we can go from there. All right. That are at or above that. What? No.
Re-explain the whole random or significant thing to me again.
Okay. All of these that are showing in the dot plot are all by random chance. They reshuffled it. They did the mean for A, mean for B, subtracted them, plotted it, shuffled them all up again. Mean for A, mean for B, subtracted it. Okay? So you do see how our value is with the random ones, which it's all within. If it was way out here, it probably didn't happen by random chance. So that means it's significant if it was way out here. We okay? All right. 95 of them. All right. So you guys don't have to, you're going to make me count them all. Nope. 95 out of, I think it's 250 they did. 95 out of 250 gives me what percent, even though we know it's going to be a 95 out of 250. What percent are at or above? 3? 38? Okay. 38%. You guys are animals. Thank you. Thank you. Appreciate it. Okay. All right. So 38%. So is there significant difference? I want to make sure we can answer this correctly because this is where you guys get confused. Is this 0.28 significant or not? No, it's only significant if it's on the outside. Okay, everybody good. It's happened by random chance, so it's not significant. So no. And here's our what? Go ahead, Grace.
I don't know why that doesn't make any sense.
Okay. The 0.28 is when we separated them ourselves, right? So what I'm trying to show you guys is it doesn't matter if I did it this way or if I just shuffled all these and dealt 5, 5, 5, and 5. I'm still going to get a number that's random. The 0.28 that we observed is still with it. Didn't matter if I shuffled them or kept them separate or not. Okay, if it was way out here, that's unusual. Right?
Yeah. I don't know.
You're not the only one, trust me. Okay? So this 0.28 wasn't because it was by chance that happened. Okay? It wasn't significant because it wasn't outside here as like an extreme value. Okay?
Past what is it considered?
What percent? 2.5% or below is considered unusual. Okay? It's significant if it didn't happen by random chance. How about that?
Okay. Yeah.
Okay?
Yeah.
You sure?
Yeah, I'm sure.
Okay. Well, we're going to do a couple more, so don't worry. So no, 0.28 falls within what level of confidence? Falls within our 95% confidence interval. Hey, and don't feel stressed out. I get it. It happens every year. All right, it happens every year with this unusual. It's hard concept to understand. Why the heck do you think we save it for last? This is the very last thing we do in Algebra 2. Nope. Yeah, 37. Going into the review part now. A lot of plants today. Now it's synthetic light, and this Mia girl thinks synthetic light will have a slower growth than natural light. So here are facts for synthetic, here are facts for natural. Calculate the difference in the means now. Ready? Calculate the difference in the means. I'll do this one with you. And it's x2 minus x1. So the mean for treatment 2 was 24.1 minus the mean for treatment 1, which is 17.9. What's the difference in the means? 6.2 centimeters. Okay, everybody stop. We're not ready to go to the simulation yet. Does this calculation only, I'm not ready to go down here. Does this calculation support her belief that synthetic light grows slower than natural light? Does that at least support her claim? Yes, it does. Why? Because, here we go, on average, what do you know? What's this telling you? On average, natural light plants, yeah, we got it. Natural light plants grow 6.2 centimeters more. So far she's right. So ready, Grace? Now we're going to figure out, ready? If that is just by random chance, we put the higher growing plants in one group than the other, or is this actually because, yeah, it's true, natural light do grow more. So we go to the dot plot down here that she did how many times? 100 times. Where's 6.2 on here? Where's our observer? Right here? Do you see how it's totally outside all the random chance ones here? Well, these are all by random chance, but it's not towards the middle group here. All right, so this is a little unusual. Okay? Let's just make sure it's unusual. How many are at or above? 1 out of 100. So that tells me there's only 1% that are at or above that one. So is it statistically significant increase? Yes. Yes, it is because of the light, right? It is because it falls outside our 95% confidence interval. So falls outside. If it didn't have an effect, it would be like all the rest of them. All right, but this is unusual here that the one we looked at is way out here. A little unusual for that to be out there. So it is significant. Everyone all right there? We okay? Going? Anything you want to ask? Because I think this is the last one we're doing together. You'll do another one tomorrow during review, but anything you want to ask? Because we're going on to the review now. Yeah. Test review time. Anybody else want to clap? Nope. Nope. Only one? That's okay. I'm going to keep going. Lone wolf. I don't care. Is it annoying some of you? Good. That was my purpose. Good. Number 17 on the review. Sorry, Kylie. Anybody feel like talking here where you're going to in a second? Test review time. Battery. Number 17, battery. Lifetime span of 60 hours. Standard deviation of 5. It's normally distributed. Time out. Time out. Everyone see those words? Love them. Because where do I get to work solely if they've been normally distributed? Right on the calc. What's the percent that are at least 70? Well, first of all, where do I go on the calc for normally distributed problems here? Where do I go on my calculator? Oh, let's hear from 16. How we doing? Oh, that kid. 16. 5? I know that. I was just wanted to stare. Hey, great job, as usual, all year long. 1. Come on, you got it. Yep, normally distributed. Where do I have to go on that on the calculator? Remember, look, all right, there's nothing to put into a list here, so I don't want to go to list or one var stats. Remember where to go instead? Second. Go. Second vars, yep. And remember, you see the word above vars? Yeah, distrib. Yeah. Where do I go now? Yes, normal CDF. Nice job. Normal CDF. What do I plug into normal CDF? Ready? Lower bound. Uh-oh. At least 70, guys. At least 70. You have at least $70 in your pocket. What are you telling me? 70 or... Oh, boy. 70 or more. Yes. So 70 or above. Let me turn this over to somebody else now. 10. What's going to be your low one then? 70. There is no cap at the high value, so what do I end up putting in? What's the highest number I can put in? 7. Oh, that's right. You were the lone one not here. Ready? 70 is my lower, right? You got that on your calculator?
I don't understand. Are you over school today?
Yeah. At about 2:30, because I got to go a quick meeting next door at 2:15. Okay, so 70. You see how there's no upper bound, you know? Okay, so I don't put in a number. I actually put in the highest one my calculator can hold, which is 1. And then right above the comma button, you should have a double E, right? And then 99. Okay. Now let's say you needed to reverse it, and the lower one you didn't have one for. Now you just change that to -1. E99, all right? The next one is that little U, which is the mean. What's the mean in this problem? 15? 60? And then the standard deviation? 5. So that's what's going to go in there. Remember, that's what you show me for work if it's not a multiple choice question. Everyone all right what I plugged in for normal CDF? You get an answer out. That's as a decimal, but I need it as a percent. And let's go nearest tenth on this one. I need it as a percent. So what percent are at least 70? Last at least 70 hours. What percent to the nearest tenth? Oh, 18. 2.3%. Good to see you back, Ian. You were missed. Questions? Ready? Because this next one's going to take a little turn. How many of 1,500 batteries are within 1? Your calculator's not going to help you here. Ready? If it's normally distributed, I gave you guys 2% when we did this. 1 for within 1, 1 for within 2. If it's normally distributed, anybody remember the percent for within 1? 68%. Yes, for within 1. 68% of the 1,500 are within 1. Anybody remember for within 2? Within 2 was about 95%. I don't know if 95, I won't even go into it, but yes, it does relate to that confidence interval we've been dealing with. If it falls past 2 standard deviations, yes. I don't know what that is next to the 68. Sorry. Okay, so because it was normally distributed, of the 1,500, 68% are within 1 standard deviation. How do you find how many batteries then? Of the 1,500, 68% are within 1. No normal CDF here. All right, let's dig deep. 13, lucky. What do you got, Rachel? What are you doing? Just okay, so you're setting up a proportion. That's one way. All right. Guys, there's 1,500 batteries. We know 68% of them are within 1. So what can I do with the 1,500 and the 68? Yes, no? Well, I don't know if I'd set up a proportion, but that's one way to get to it. I would just multiply it by 0.68. How many batteries? What was it? 1,020? Mm-hmm. Only way you can use 68% if it tells you it's normally distributed. Okay? Only way you can use 68% within 1 is if it's normally distributed. What if it's not normally distributed? Great question. That's why I set it up like I do here. Genius. Go to number 13. Everyone have a great weekend. Good to hear. Looking forward to break. Great. Anybody going anywhere? No? All right. Let's just keep going. Just had to get those questions out. I'll do it earlier in the week. All right. I care. I do. And I do care. I do. Where you're going or what you're doing over break. What? I do. I'm sincere. Hey, it's all real with me. Not going to sugarcoat anything. Here you go. Here's the number of vacation days. Yeah, 15. Ooh, at the Chase Titanium Metals Company. Wow. Who would not want to work there, huh? What percentage of data fall within one standard deviation? Oh, this is easy. It's 60%. No, it's not. And not unless it's normally distributed, can I use 68% or within one. So we're actually going to have to calculate. Ready? Here's what you're going to have to calculate for me. How many are within one? How many fall between here? So what are the two values I'm going to need here? I'm going to need standard deviation and the zero number, which is the mean. Yeah, I'm going to need to know what it is at zero. I need to know what the mean is. How can I get those values? Don't say anything. You're good at that. 4, how can I get those values? For the mean, but I also need the standard deviation. Darn right. Look at that. Generator knows, Gabe, who to call on at certain points in the class. So you guys are going to need the mean and standard deviation. Let's go nearest 10th. Go nearest 10th. Okay, mean and standard deviation. What'd you get out of that? After you went to one var stats. Here you go. 13. What'd you get out of that, Rachel? The mean, about 4.1. Yep. And how about the standard deviation? About 3.3. Yep. Okay, what do I do with those numbers now? Ready? Here's my mean right in the middle, 4.1. How do I find what's at plus 1? Add the standard deviation. So that should be a score of 7.4. And how do I get to negative 1? Subtract it, and that should give me 0.8. All right, you guys, count them up. What's the percent of scores that fall between 0.8 and 7.4 now? Count them up between 0.8 and 7.4. How many did you find are between there? Here you go, 8. How many did you find between there? 10 out of 15. For a percent, about 67%. So hey, these could have been normally distributed, huh? Those values came pretty close to 68. Yep, could have been normally distributed. We okay there? Okay, here's how we're going to end class. You do 10 and 14 on your own. 10 and 14 on your own. I'll put the answers up here. You check your answers as you go along, all right? 10 and 14. You guys are just starting. I'll put 10 and 14 up. If you forget a formula, let me know or look it up yourself.